Hello everyone, welcome back. So in the previous videos, what we have seen in the AXI starting introductory video is we have discussed the case scenario, why we needed AXI, what was the reason we required AXI. We have taken an example of CPU and memory, where CPU was acting as a master. It was demanding some data from memory or wanted to write to memory. I want to establish one connection between them. I need some of the requirement. I have some of the requirements for this connection, which we have seen these are. So AXI was the one which was fulfilling all these requirements. Next, we have seen how AXI was fulfilling our requirements. What exactly was such in AXI that our requirements was fulfilled with AXI. What is AXI we have seen, and the characteristics of AXI we have also seen. Next, we have seen the AXI channel architecture. There are 5 channels in AXI: the write request channel, write data channel, write response channel, the read request channel, and the read response and data channel. We have seen the data signals of each channel. There were some of the control signals also included in each channel. We have seen that these valid and ready signals are common among all the channels. Why this is so? Because these are handshaking signals, and then rest other their channel individual signals. For example, write address for write address channel, write data response signal, read address and read response signal. So we'll understand why all these signals are common among all the channels. What exactly is a handshaking signal? How handshaking happens, we'll see today. So the core concept of handshaking, when we say what exactly handshaking means. When we say handshaking, handshaking simply means there is person A, there is person B. They are meeting for the very first time with each other. Now person A will say hello. So he introduces, or he or she introduces himself to B. So B knows that there is some person named A exists. Now in response, B introduces himself that hi, I am B. So now A also knows that there is some person named B. So the handshaking between them is completed. So you see there are two introductory signals included. One A is sent by A, one is sent by B for them to get introduced. So how in our digital world handshaking happens? We have one master. I will say source, not master. Then we have one destination where source wants to send the data. Now in this case, what happens is source, whatever the data source is having, it will send it to destination, and it will at first, before sending the data, what it says is I have some valid data. By sending valid signal, it indicates, the source will indicate to destination that I am having some valid data. So destination will get to know that yes, there is some valid data which I can receive. So once destination sees that now I am available to receive the data, so it will send one signal to source named ready signal. It will say now I am ready to receive your valid data. So using valid and ready, the handshaking has been completed. Both source and destination now knows each other, and they have communicated for the process of the data, that when you can send the data. So how this happens is, we'll see it based on a waveform. So let us say we are having one source over here, then we are having our destination. So in our case, I'll take, in AXI case, I'll take it as our master wants to write some data and to our slave memory. So during the clock cycle, when the data is available, this is the data which is available to be written. So once the data is available, the source or master, I'll say, or CPU will assert valid signal high. So once the valid signal high is asserted, the destination will get to know that there is some valid data. This data is there with source. So source has informed destination that I'm having some valid data. So next, in response, either in the same clock cycle, that means when we say in the same clock cycle, either in this clock cycle or further upcoming clock cycles, the destination can send the ready signal. So once the destination is available, it will assert the ready signal. This ready signal has been asserted over here, and valid signal is also high during this clock cycle, if you see. So during this clock cycle, when valid is also high, ready is also high, the data transfer will happen. So this is the clock cycle where the data transfer happens. So now we'll see some of the case scenarios. So if we are having one source, the source can be master in our case, or it can also be slave. That means when the master is source, obviously the destination will be slave, and if slave is the master, the destination, slave is the source, the destination will be master. How it happens, we'll see using example. For example, I want to write a data. My master wants to write a data to slave. So it will send a signal, valid signal. It says I am having some valid data and I want to write it to you. The slave will send a ready signal that yes, I am also ready. You can write this data to me. But let us take a case where I am having master and slave. Master has sent a request to slave. This is a request that I need some data from this address. So before sending the data, slave will send one valid signal that I have data ready from the address which you asked. Now I have that data, valid data which you ask. So in response, master will send a ready signal. It will say yes, I am ready to receive the data. So while reading, we can see slave has become the source as it has sent the valid signal, and master has become the destination as it has sent the ready signal. Next, we'll see some of the restriction and case scenarios. Let us say one case scenario is we are having these clock cycles. Under this clock cycle, we are having a data. This is clock. We are having data which starts from over here and goes up to here. This is our data. Next, we are having the valid signal. So when valid will be asserted, because at this point we have started receiving the data, and valid will be high throughout all this. In the next clock cycle, what is going to happen is this is valid. Now this is ready signal. This is the case in same clock cycle when we are receiving this. So in this clock cycle, in the same clock cycle, the valid was high, and in the same clock cycle, thus destination has said now I'm also ready to receive the data. So in the same clock cycle, what happens is ready will also become high, and the ready will become high and the data will be transferred during this clock cycle. If the valid is high for, if you see this is 1.5 clock cycle, if the data is valid for this much time, so for this much time the ready will be high, and during this period the data will be transferred. But usually how it happens is, it doesn't happens it like this. For this particular only single clock cycle, if the data is valid also, and for the same clock cycle the ready is also high, so the data will be valid up to when? Data will be valid up to this point, because once the valid goes low the data is also not valid. So during this cycle, when the valid is also high and the ready is also high, so in this clock cycle, this one, that means this clock cycle, data transfer happened. So this was the case where same clock cycle, data transfer. Next we are having the case which we have seen over here. This was different clock cycle when valid was high and the ready signal was not received, so the source was waiting by keeping the valid high. So this ready might have received over here, or it might be received over here. So if it has received over here, it was the responsibility of source to keep valid high until this point, and the data will also be available till valid was high. So data will be available till this point. This point data will be there, right? So that means until and unless the ready signal has not been received, the transaction will keep on hold and it will keep on extending. So based on this, there is one rule, one constraint which has to be followed while doing handshaking is, once valid is high, it can't go low until and unless ready becomes high and data transfer happened, right? So this is one of the important point need to be keep in mind while doing handshaking. So based on this, what are the pointers we have seen? Using ready signal, the transaction can be extended. The transaction can be extended, right? Because if the ready signal has not arrived, the valid and the data have to be there on the channel. The valid signal have to be high, and once the valid is high, the data will also be valid and it will be there, right? So this was the overall handshaking scenario which we have discussed. Next upcoming what we'll be discussing is the whole concept of write address channel, the signals, the unique ID concept, the burst length will be taking care of. We'll be also understanding the beat, burst, transfer, transaction, then the signal descriptions, then the burst size, burst length. Will be seeing all how the total data is transferred. Different burst types will be seeing: fixed, increment, wrap, burst. Then using one example, we will be seeing the working of one write address channel. So this next video is going to be very important. This will create the base for your understanding of the AXI transfer. how actually it happens. So once you understood this concept, one right data address channel, right address channel, next upcoming channels will become very easy for you. If you fail to understand this particular right address channel, your other links will not be established and you will not be able to understand further channels. So pay attention on this one. Keep connecting, keep learning. See you in the next video. Thank you.